This is Autumn Co's final project, and I'm going to teach you how to find the volume of an object using the washer method. The example problem will be to find the volume of the region bounded by the equations y equals 2x plus 7 and y equals x squared minus 1 rotated about y equals negative 3. First, we should get a picture of the graph by drawing it. Here is y equals 2x plus 7. And here is y equals x squared minus 1. Now we have to rotate it about y equals negative 3, which will be down here. The graph will look like this. In order to find the volume, you need to rotate it, which will make it look like a washer. And the points where the two equations intersect are negative 2, 3, and 4, 15. This will be important later. Now we can start solving the problem. The volume of any spherical integral is modeled by this equation. Volume equals pi r squared times change in x. Because it's a washer method, this ends up looking like this. Big R squared minus little r squared dx. Looking back at our graph, we can remind ourselves that the points of intersection occur when x equals negative 2 and 4. We then use these points of intersection to figure out where our bounds would be, here and here. So it end up looking like pi negative 2 to 4 big R squared minus little r squared dx. Once we put in the equations, it'll look like this. dx. Now, since it's bounded about y equals negative 3, we have to take that into consideration by subtracting it. However, since it's a negative, we need to add 3 to both sides. Now that we have our integral, we need to find the antiderivative of this function. However, the easiest way to do it would first be to simplify. So this will become 2x plus 10 squared minus x squared plus 2 squared dx. And it's still in the integral. So negative 2 to 4, all times pi. Now we can factor it out, which will make it even easier to find the antiderivative. Once it's all factored, this will be the function. Negative x to the 4th plus 40x plus 96 all dx. Now that we have a simplified integral, we can finish up the problem. Pi times the integral of negative 2 to 4 all of negative x to the fourth plus 40x plus 96 dx. First thing we have to do is find the antiderivative of this function. So we bring it down, multiplying x, so it'll be negative x to the fifth. However, we need to get it back to negative 1. So in order to do that, after we bring this down, we have to multiply it by 1/5. Next, we take the 40x and we bring it down, so x, and then we multiply it by another x, which will make it x squared. In order for it to go back to 40 once we multiply the 2 up front, we have to make it 20x squared. Next, we just multiply x to the 96. Lastly, we have to add a constant, which we do not need to solve for. After we have this, the whole antiderivative, we will need to evaluate it from negative 2 to 4. Then multiply that all by pi. In order to evaluate it, we need to plug this 4 into all the x's and then subtract it from this whole function with the negative 2 plugged in all the x's. So we'll do that here. Negative 1/5 times 4 to the 5th plus 20 times 4 squared plus 96 times 4. And then we don't need to include the c because it'll cancel out with the c from the function with negative 2. So once we have this, we subtract it from negative 1/5 times negative 2 to the 5th plus 20 times negative 2 squared plus 96 times negative 2. And then we multiply this all by pi. Once we have all this, we can simplify it with our calculator, and it will come out to 3024 pi over 5, which roughly equals 1900.035. And there you have it. That's the answer to the volume of this problem.